Morning all. Hope everybody doing good. In our last video, we discussed about the dot convention. In that one, we discussed lastly about the couplings. Okay, that is electrical and the magnetic coupling. In this video, I'm going to explain about how to calculate the equivalent values for a electrically coupled networks. Okay, so first thing is electrical aiding type means the current has to enter or leaves in the both dotted terminals. Okay, that is what aiding type guys. Kindly remember, current has to enter or leaves at the both dotted terminals. In the two coils, current has to enter. So I shown the figure. In this figure, both current enters at the dotted terminal. Then only it is we are calling as a series aiding. Or else we can say another term is current has to leave, means in this place in the coil 1 we have to place in the downside, and coil 2 also we have to place in the downside. Then it is also series aiding type, means either current enters or leaves from the dotted terminals, we are calling as a series aiding type. As we know that two coils are in series means the current flowing through the both the coils are same. Okay, so the current flowing through L1 is I1, the current flowing through L2 is I2. In series, we know that I equals to I1 equals to I2. So I'm using I only. Okay. Next, if I use the KVL equation for the given network, that is what I shown here. Okay. So how we are going to write the self-inductance? I'm always writing in my equations self-inductance E equals to minus L dA by dt. That is what the self-inductance formula. Okay. So for this one, minus L1 di1 by dt. That is what I have to write for a self-inductance of coil 1. Is it true? So how we are writing? Minus L1. Okay. Minus for Lenz's law. L1 is the self-inductance. di1. So the current flowing to coil 1 is I1 by dt. Okay. So L1 minus L1 di1 by dt. Okay. So how I am writing? We know that in series I equals to I1 equals to I2. So I'm writing as a minus L1 di by dt. Okay. So how I am going to write the mutual? In the both the cases, current entering at the dotted. So the symbol whatever I use for the self-inductance, the same symbol as follows for the mutual inductance. So if I use it for a minus means the same negative symbol I have to use it for the mutual inductance. That is what I said in my last video. Okay. So I use it the minus, so that minus M di by dt. Okay. So the first mutual inductance is over. Okay. Then how I am writing? That is M12. I've written for M12. Okay. Now I am going to write for equation for second coil. In the second coil, inductance is L2, current is I2. So how I am going to write the self-inductance, self-induced voltage minus L2 di2 by dt. Okay. So as we know that in series current is same. So minus L2 di by dt. Okay. Guys, mutual inductance is linked from 2 to 1 also. Okay. Guys, M we have a M12, M21. Okay. We know that M12 and M21 is equals to M. So I'm using M only. Okay. So in first case I've written M12. Now I am writing M21. In the both the cases, current entering at the dotted terminals means the same sign of self-inductance. So the sign of self-inductance is minus L2. So I am writing the minus M di by dt. From negative to positive, the voltage is V. I am writing positive voltage. Okay. So this is my KVL equation. Okay. Next, from that one, V equals to how we are going to write. So in the both the cases, minus M di by dt minus M di by dt. How it will comes? Minus 2M, sorry, minus 2M di by dt. If I send the whole thing to opposite side, L1 di by dt plus L2 di by dt plus 2M di by dt. If I take a common of di by dt, the terms will be in the first term L1, in the second term L2, in the third term 2M. Okay. So we compare this equation with L equivalent dA by dt means we get L equivalent value as L1 plus L2 plus 2M. So this is your equivalent inductance when two coils are series aiding. Okay. So this is the formula for the series aiding. Similarly, we are going to see for the series opposing also. Okay. Means current entered into one dot has to oppose the in another coil. Okay, so in this case, current entering at the top side. In this case, current entering at the bottom side. So both are in opposite direction. So I am saying these two are in series opposing. We have another circuit also. If I place down dot over here, top dot over here also, it is also a series opposing circuit. Okay, so how we are going to write? The first one is minus L1. Both are in series, so current is same. I1 equals to I2. So minus L1 di1 by dt. How we are going to write? Minus L1 di by dt. So what is the mutual inductance? It is in opposing nature. So how we are going to write? The sign of self-inductance has to oppose, means in this case the sign of self-inductance is minus, so we have to write the plus. Okay, that is the opposite sign. So for a minus L, we are considering the for a series opposing plus M di by dt. In the second case, how we are going to write? Minus L2 di2 by dt. How we are going to write? Minus L2 di by dt. Okay, how we are going to write it for M21? M21 is also opposing in nature. So how we are going to write? The opposite sign of L2, that is plus M di by dt. Okay, so di by dt means the current flowing to the two coils are same. So I'm using only I. Okay, the same voltage is plus. So if I consider V equals to I send all things to in this side. So this one will become minus 2M. So if I take a common of di by dt means the total L equivalent is L1 plus L2 minus 2M. That is what I write over here. Okay. So we derive the two things. If we have a electrical coupling, series aiding and the series opposing, the L equivalent for a series aiding is L1 plus L2 plus 2M. The series opposing is L1 plus L2 minus 2M. Okay. Similarly, we have another coupling, that is magnetic coupling, means there is no physical contact between the two coils. So in the first case, we have a current entering into both the dot terminals. So we are saying this as a series aiding. Okay. So how we are going to write? The first equation is minus L1 di1 by dt. In this case, the current M di1 by dt. Okay. So this is for first one. This is what I represented. Minus L1 di1 by dt minus M di2 by dt. Okay. So next, how the same thing I've written in equation 1. Okay. The symbol is quite opposite. Okay. The second case, V2. Sorry, in the both L1 and M having the same polarity. In the second equation, in a second coil. So in this coil, the current is I2 is flowing. So minus L2 di2 by dt. By this one, the current flowing to the induced EMF in this one is so minus L2 di2 by dt minus M di1 by dt. Okay, hope you understood. So if I send this one, it is I'm representing as equation 2. I repeat how I said. Okay, guys, from the I1 current, the self-induced voltage is minus L1 di1 by dt. That is what we know. Okay, by this I1 of current flowing, there is a induced voltage over here in the second coil. That is, I have to write as a M di2 by dt. Okay, the sign of the M is the same sign of L1. That is what. So the sign of L1 is minus. So I consider the M sign as also minus. Okay. So I represented in this way. Okay. So the both the cases, the sign of the L1 and M is and L2 and M is same. So I am saying these two are magnetically series aiding. Okay. So in this case also, they both are having the opposite sign. Means this case current entering at the dotted terminal. In this case, current leaving at the dotted terminal. So I'm saying these two as a opposing. Okay, magnetically opposing and opposing side. Okay. So how I am going to write? The first equation is minus L1 di1 by dt. Okay, because of current I1, I am writing the self-induced voltage as minus L1 di1 by dt. How I am going to write the M opposing? Means if I use the minus L1 means I have to use the plus M di2 by dt. Okay. If I send these two terms, L1 as having the positive polarity, M having the negative polarity. For a second coil, the current is I2. So how I am going to write? minus L2 di2 by dt. Okay, always the self-induced voltage is I am writing as a negative polarity only. Okay, minus L2 di2 by dt. How I am going to write the mutual inductance? Plus M, because the opposite sign I have to write. Okay, so both are having the opposite signs. So self-inductance voltage and the mutual inductance voltage is having the opposite signs. So I am saying that these two are magnetically coupled but opposite in type. Okay, thank you guys. Hope you understood. Have a nice day.